Welcome dear viewers. In my earlier lecture on bioinorganic chemistry, I have discussed the porphyrins, metalloporphyrins, hemoglobin, myoglobin, their structure, their role in the body and Bohr effect and cooperativity. In my today's lecture, I will be discussing the nitrogen fixation. So, the lecture plan of my today's lecture goes this way. First of all, I will be discussing nitrogen fixation, the natural methods of nitrogen fixation, then I will be taking denitrification, structure of the enzyme nitrogenase, the artificial methods of nitrogen fixation and the nitrogen cycle. We all know that the air is comprised of 78% nitrogen, 21% oxygen and the remaining 1% is all the other gases. When nitrogen is present in such a large amount, that is 78%, that is a major component of the air is nitrogen, then it must be having some useful role to play on this earth. So, what is the role of nitrogen? This nitrogen is basically used by the plants for their normal growth, but it is not used in its free form, like it is present in the form of N2, the free gas, but it is not used like this. It has to be converted into some useful form which can be easily absorbed by the plant. So, this conversion of free nitrogen into some absorbable form by plant is called nitrogen fixation. So, in other words, we can say the conversion of atmospheric nitrogen into useful nitrogenous compounds by natural or artificial methods is nitrogen fixation. Nitrogen present in the nitrogenous compounds is called fixed or combined nitrogen. Now, I will be taking the natural methods for nitrogen fixation, like how is the nitrogen present in the air, it is converted into some useful form which can be absorbed by the plant. The first method of nitrogen fixation naturally is by lightning discharge. Here the free nitrogen, it combines with oxygen in the presence of lightning. Lightning means whenever there is cloud and lightning in the sky, then this nitrogen it combines with oxygen to form NO. NO is nitric oxide. This nitric oxide it further combines with more of oxygen to form nitrogen pentaoxide, that is N2O5. Now, this nitrogen pentaoxide it combines with water to form nitric acid, that is HNO3. This HNO3 it comes down or it mixes with rain and it comes down to the soil and it forms calcium nitrate or other forms, and this nitrate is used by the plants. The second method of naturally fixing nitrogen is by symbiotic bacteria. Symbiotic bacteria are the bacteria which have some symbiotic relation with the plant, or we can say some friendly relation with the plants. Friendly in the sense like plant provide the shelter and food to the bacteria, and the bacteria in return it fixes the nitrogen for the plant. The atmospheric nitrogen is being constantly transferred to the soil by symbiotic bacteria like rhizobium. They grow in the small nodules present in the roots of the leguminous plant like pea, gram, beans, all these are leguminous plant, and these directly assimilate atmospheric nitrogen and convert it into product which are useful for plant growth. Free nitrogen and ammonium salts are converted to nitrites in the presence of nitrosifying bacteria, and the free nitrogen and ammonium salts are converted to nitrates in the presence of nitrifying bacteria. So, the different bacteria these convert the same reactant into different products. The final product nitrates it serves as plant food, that means plant does not use the free nitrogen, but it converts it into nitrates and then it uses it. This process of oxidation is known as nitrification and it causes the combined nitrogen to be available to the plants. The species of rhizobium is specific for each plant species. That means every plant will have a different species of rhizobium which is present in its root, which will fix nitrogen for it. Cyanobacteria, which are also called blue green algae, these perform nitrogen fixation in oceans. All these microorganisms produces ammonia through the activity of nitrogenase. Nitrogenase is basically the enzyme which converts the free nitrogen into ammonia or nitrates, and it is present in the microorganism. Most of the free nitrogen bacteria perform nitrogen fixation anaerobically. Anaerobically means in the absence of oxygen, like they do not require any oxygen and then they fix this free nitrogen. But the cyanobacteria, which is the blue green algae and perform nitrogen fixation in oceans, it fixes nitrogen aerobically, that is it fixes nitrogen in the presence of oxygen. This is the figure which shows the root nodules in the leguminous plant. So, we can see this is the root of a leguminous plant, it has some swollen part on it. These swollen part are basically the home for the bacteria, that is the rhizobium. The rhizobium bacteria, it lives in this nodules or the swollen part and fixes nitrogen for the plant. Here we can see in this figure the nitrogen, which is the unreactive and the insoluble form, it gets converted to the ammonium ion, which is reactive and the soluble form and which is used by the plant. This is done in the presence of the enzyme nitrogenase. Here 3-ferredoxin, the reduced form, it converts to the ferredoxin, which is the oxidized form. That means the ferredoxin is being oxidized, that means it is losing electrons, and this reaction involves 3 molecules of ferredoxin which donate 6 electrons, and here ATP is also consumed because the energy is required in this process. Here 12 to 18 molecules of ATP are consumed to supply energy and this ATP is converted to ADP. Coming on to denitrification. The nitrogenous compounds present in the soil, these are converted back to the free nitrogen with the help of denitrifying bacteria, and this free nitrogen, it goes back to the atmosphere. If all the nitrogen was fixed by the nitrifying bacteria into some nitrogenous compound, then a time would come when there would be no free nitrogen in the atmosphere. But this does not happen because there are some denitrifying bacteria which convert the nitrogenous compound, that is the fixed nitrogen, it is again released free by these denitrifying bacteria into the free nitrogen. And because of these cycles of changes which are constantly going on in nature, the total average amount of gas in the atmosphere, it remains unchanged. That means before thousands of years back, the percentage of nitrogen was 78 and today also it is 78. Nitrogen, the free nitrogen, it gets reduced to ammonium with the help of some enzymes. The main enzyme involved here is nitrogenase, which is present inside the microorganism. The main reaction occurring in this process are the nitrogen, it is reduced with the help of 6 electron to form ammonia, that is NH3. In this ATPs are required. ATPs are required because this is energy consuming process. So, 16 ATP to 18 ATPs are required here and this nitrogen is converted to ammonia and free phosphate is released, ATP is converted to ADP. Ammonia may be further converted into nitrate or nitrite or directly used in the synthesis of amino acids or other essential compound as required by the plant. This reaction occurs at atmospheric condition of temperature and pressure in rhizobia bacteria in the root nodules of leguminous plants. The fundamental features of nitrogen fixation process. The bacterial enzyme which causes the nitrogen fixation is nitrogenase. This nitrogenase enzyme catalyzes the process of fixation. Strong reductant like ferredoxin behaves as an electron carrier with a very low potential. It requires energy and this energy is supplied by the ATP, that is adenosine triphosphate in biological processes. Anaerobic condition is required. As I have already said, this fixation occurs in the absence of oxygen. Only cyanobacteria perform this process in presence of oxygen, that is aerobically. Coming on to the enzyme nitrogenase. This enzyme is at the heart of the nitrogen fixation process because this is the enzyme which is converting free nitrogen to the useful nitrogen. It catalyzes the conversion of molecular nitrogen to ammonia and this enzyme consists of 2 metalloproteins. Metalloproteins means the proteins which contains some metal. The first part is iron protein, which is also called iron sulfur protein or nitrogenase reductase. The second metalloprotein is molybdenum iron protein, which is also known as molybdenum iron sulfur protein. Nitrogenase is a complex of two proteins which are in dynamic equilibrium with its components. So, we can say that molybdenum iron protein part plus the second part, which is iron protein, these two combine together to form nitrogenase complex. Thus, nitrogenase are the complexes of iron sulfur protein and molybdenum protein whose activity couples ATP hydrolysis to electron transfer from ferredoxin for carrying out the reduction of free nitrogen to ammonia. Let us discuss the first part, that is iron protein or iron sulfur protein, which is also known as nitrogenase reductase. It is a smaller protein with molecular weight of 50,000 to 70,000. It is also known as azoferredoxin. It is yellow in color and extremely air sensitive. It contains Fe4S4 cluster, which is known as ferredoxin core. It binds magnesium ATP and hydrolyzes 2 ATP molecules per electron transferred during nitrogen fixation. The reduction of free nitrogen to ammonia requires 8 electrons. Therefore, 16 ATP molecules are consumed per nitrogen molecule reduced. So, we can see that nitrogen, it consumes 16 ATP, N2 molecule consumes 16 ATP and it gets reduced, that is, it is taking up electrons to form ammonia. This reaction can also be shown in this way, that nitrogen is being reduced with the help of electrons into the ammonia, and here 16 ATP are converted to 16 ADP. The second part is molybdenum iron protein, which is also known as molybdenum iron sulfur protein. Molybdenum iron cofactor or molybdenum iron protein contains both molybdenum and iron. Therefore, it is known as molybdenum iron protein or molybidoferredoxin. It is a larger protein with molecular weight of 2,20,000 to 2,40,000. It is brown in color and air sensitive. This is the structure of the iron molybdenum cofactor. Here we can see that iron is linked through weak interactions, and sulfur atoms are also present in this molecule, and this molybdenum is present here. It contains molybdenum, iron and sulfur. It consists of 2 molybdenum Fe3S3 cluster joined by 2 bridging sulfide and 3 ligand designated as Y, which is a less ordered sulfur species. The iron atom is in the center and interact with each other through this has been shown through dotted line in the earlier figure. The iron bond distance is about 2.5 angstrom. This is the model for binding of nitrogen to FeMO cofactor. Here we can see that since this iron interaction was very weak, so this nitrogen it easily comes in between this iron and forms multiple bonding with the iron. FeMO cofactor contains 3 weak Fe bond. These are destabilized due to distortion from ideal tetrahedral geometry. Therefore, nitrogen binds in the center of the iron molybdenum cofactor, thereby replacing the weak Fe bond with multiple iron nitrogen bond having approximately the sp3 or tetrahedral geometry. As a result of iron nitrogen interaction, the sp2 hybridized N triple bond N bond gets weakened, thereby lowering the high activation barrier for nitrogen reduction. Now, coming on to the artificial methods for nitrogen fixation. These were the natural methods by which the nitrogen is being fixed by the plants, but sometimes we find that we use some fertilizers in the fields because there is deficiency of nitrogen and other elements, like we have NKP fertilizer. NKP is basically nitrogen, potassium and phosphorus fertilizer. So, this in these fertilizers nitrogen is there. So, artificially we have to fix the nitrogen in the laboratories and we change it into some useful form which is being used by the plant. So, the first method for the nitrogen fixation artificially is fixation of nitrogen as HNO3, that is nitric acid. Under the influence of high tension electric arc where the temperature is high, nitrogen of the air combines with oxygen to form nitric oxide. N2 plus O2, this form NO, that is nitric oxide. Now, this nitric oxide combines with more of oxygen to form nitrogen peroxide. So, we have NO This is nitric oxide, it combines with oxygen to form NO2, that is nitrogen peroxide. This may be absorbed in water in the presence of excess of air to form nitric acid, which may be used for the manufacture of nitrogenous fertilizers. This is nitrogen peroxide, it combines with water and oxygen and forms nitric acid. The second artificial method for nitrogen fixation is fixation of nitrogen as ammonia or ammonium salts. Haber's process is used for the manufacture of ammonia. In this process, a mixture of nitrogen and hydrogen is taken in a ratio of 1:3, which is compressed to a pressure of 200 to 500 atmosphere and is passed over finely divided iron and molybdenum, which are used as catalyst, and it is heated up to 550 degrees Celsius. So, here nitrogen combines with hydrogen in the presence of catalyst and at high pressure to form ammonia. This ammonia can further be converted to ammonium salts by the treatment with suitable acids. Next method for fixing nitrogen artificially is fixation of nitrogen as calcium cyanamide, that is CaCN2. Nitrogen gas is passed over calcium carbide. Calcium carbide is CaC2, which is heated to 800 to 1000 degrees Celsius. A mixture of calcium cyanamide and carbon is obtained, which is extensively used as a fertilizer under the name nitrolim. So, calcium carbide, it combines with nitrogen to form calcium cyanamide plus carbon. This complete complex, it is called nitrolim. This is a fertilizer which is used in the fields. Next method for the fixation of nitrogen is fixing nitrogen as nitrides. Here nitrogen combines with magnesium and aluminium at high temperature to give nitrides, which are employed as a source of ammonia. Magnesium, it combines with nitrogen to form magnesium nitride, that is Mg3N2. Even aluminium can be used in this process. Aluminium, it combines with nitrogen to form aluminium nitride, AlN. These nitrides are decomposed by water and ammonia is evolved. Aluminium nitride, when it combines with water, it forms ammonia and aluminium is released in the form of aluminum hydroxide. Similarly, magnesium nitride, when it combines with water, it forms ammonia, the free ammonia is liberated and this magnesium gets converted into its hydroxide. Coming on to the nitrogen cycle. The free nitrogen present in the air, it is converted to ammonia by biological nitrogen fixation methods which have been discussed in this lecture. Now, this ammonia, it is absorbed by the plants, and in plants it is in the form of organic nitrogen. These plants are eaten upon by the animals and this nitrogen is transferred to the animals. Now, these animals, these excrete and through their excretion, nitrogen is released in the form of urea. This urea is converted to ammonia, that is deamination. During decay it is converted to ammonia, free ammonia. On the second hand, the nitrogen which was present in the plant, organic nitrogen, and this organic nitrogen in animals, when these plants and animals they decay, that is they die, then they decay, this organic nitrogen is it goes to the decomposers who helps in the decay of these plants and animals, and now this organic nitrogen is again converted to ammonia by deamination during their decay. This free ammonia, it is converted into nitrite, that is NO2, and this process is called nitrification. This nitrite is converted to nitrates, NO3, nitrates are NO3, and this process is called nitrification. So, through nitrification, nitrite gets converted to nitrates in soil, ocean and fresh water. These nitrates, these undergo denitrification and free nitrogen is released in the air. Similarly, this free nitrogen, this is also fixed by lightning. As I have discussed in my first slide, it is also fixed by lightning and it converts to nitrates in the soil. These nitrates are absorbed by the plants, and similarly this cycle keep on going like this. Now, these plants are eaten upon by the animals, these animals excrete urea, and when these plants and animals they die, this free nitrogen, that is organic nitrogen, it goes into the decomposers, which again decompose it in ammonia, and this cycle keeps on repeating. On the other hand, this free nitrogen is also artificially fixed by Haber's process, that is in forms of fertilizers, and it is converted to nitrates, and this cycle keeps on repeating, and in this way nitrogen is being fixed and it is being converted back to the free nitrogen by denitrification. Coming on to the summary of my today's lecture. Today I have discussed nitrogen fixation, natural methods of nitrogen fixation, which include fixation by lightning discharges by symbiotic bacteria. We have discussed denitrification, in which I have shown that how this fixed nitrogen is converted back into the free nitrogen in the atmosphere. The structure of the main enzyme which is used for the nitrogen fixation, nitrogenase, was also discussed. This enzyme consists of two metalloproteins, iron protein, which is also called nitrogenase reductase, and molybdenum iron protein, which is also known as molybdenum iron sulfur protein. The artificial methods of nitrogen fixation were also discussed. These includes fixation of nitrogen as nitric acid, fixation of nitrogen as ammonia or ammonium salts, fixation of nitrogen as calcium cyanamide, and fixation of nitrogen as nitrides. In the end, we have discussed the nitrogen cycle, that how this nitrogen is being cycled into the atmosphere. With this, I have completed the series on the topic bioinorganic chemistry. In this series, I have included the essential and trace elements, their biological roles in the body, and with special emphasis on iron, zinc and copper, and I have discussed other elements also. I have also discussed biological role of alkali and alkaline earth metals with special emphasis on sodium, potassium, calcium and magnesium. Then I have taken porphyrins, metalloporphyrins, hemoglobin, myoglobin, and how this oxygen and CO2 are transported in the body, their mechanism, Bohr effect and cooperativity. In the end, we have discussed nitrogen fixation, the different methods which are used for the fixing of nitrogen, the natural methods, the artificial methods, the main enzyme which is involved for the fixation of nitrogen, that is nitrogenase, and we have also discussed the nitrogen cycle occurring in nature. Thank you.